Hey everyone, my name is Kyle Tutt, co-founder and CEO of Pinata, and today we are going to talk about this concept called the cryptographic cloud. So, moving into the future, all data needs to be verified from the creation of that data all the way to the consumption of the data. So, if you want to put it in simplest terms, if you took a photo from your phone and generated that file needs to make it all the way to the person that you're sharing it with on whatever app that you're sharing it, and it needs to be verifiable and it needs to be trusted. Basically, all data needs to be able to do this in the future. And the reason for this is because we are running into a problem, specifically with AI and generative AI, where it is very difficult to actually trust the data that is out there today as being real or something that we can actually rely upon. And so the cryptographic cloud exists to solve this exact problem. The number one use case that this is most used for right now today is actually within the blockchain and crypto space, where we basically use a modified or simple version of the cryptographic cloud to verify that data is real, and that verified data is then used to automate transactions through smart contracts, or it's used as a way to share data through blockchains. The other way it is being used or will be used is within the context of AI, where we need proof that this AI data that is being used to train the models is actually trustworthy and verifiable. The reason you need that is because you need high quality data to train the models to then get better outputs on the models themselves as they generate content. Additionally, we need to be able to, as I've already touched on, verify that data is real. As many of you have probably experienced, there is quite a bit of fake data being created out, especially in context of social media, where it is very difficult to trust whether or not something was real or not. The cryptographic cloud is perfectly positioned to solve those problems moving into the future, again, for both blockchain applications and AI applications. So, how is the cryptographic cloud built? Well, we actually already have an implementation of the cryptographic cloud out there, and that is with pretty much any blockchain application that is using wallets to sign transactions. When you sign a transaction using blockchain, you're actually using cryptography and cryptographic keys to sign things. Now, where blockchains fall down is that being able to store large amounts of data on a blockchain is actually extremely inefficient. If you were going to be storing gigabytes of data on a blockchain, it's going to cost you millions of dollars versus the pennies that it costs on a traditional cloud setup. And so what blockchain applications do is they store data off-chain, not on the blockchain, but sitting off-chain. The issue there is that when you store it off-chain in a traditional cloud setup, you actually lose basically all of the cryptographic properties that you get on a blockchain by storing it off-chain. To solve for that, what most blockchain applications do is they use a protocol called the Interplanetary File System, or IPFS, to store their data. The reason that they use this protocol is because it is a content addressable network. A content addressable network does something really interesting where it actually identifies each piece of content that is uploaded to the network as its own unique identifier. And so when you upload a file, what you get in return is a unique CID or content identifier for that file that is unique to that file exclusively. If that file changes at all, the CID itself will also change. And so what then blockchain developers will do, building blockchain apps, is they have the blockchain sitting over here, and they take that CID, they print it on chain, and then you have this lockstep link between the data printed on a blockchain and the data that is sitting off-chain on IPFS, and you have verifiable proof that it is what it's supposed to be. If the data changes, right, there's many use cases, most use cases, where you want to update files or you want to update data. All you have to do is then print another CID on chain, and then you have a verifiable audit log of what the data was and then what the data should be according to the application itself. And so the next step of this is that not all data out there, and I would say the majority of data that is being created today, is not actually being cryptographically signed like that. And so what we need to build the cryptographic cloud is the ability to sign all data that is generated ever. So we're going to have to be able to sign data, whether it's on your iPhone all the way to a huge computer sitting in the cloud. Every single computer that exists on the planet is going to need its own blockchain wallet that is going to be able to cryptographically sign and verify data. And you're going to need IPFS CIDs to be signed. And if you have those two things, you then have a perfectly trusted and verifiable supply chain of data, from creation to it being processed in some way to ultimately consumption and however it's being consumed. And if you have that, you can then eliminate basically all fears associated with AI tricking people and taking over the world, and having smart contracts executing on bad data and losing millions or billions of dollars. And so that is where we are going, and we're just in the early innings of what that is actually going to look like. But the foundation of it starts with blockchain, the wallets associated with it, so you have those cryptographic signatures, and then IPFS to manage and store the data. Now, why IPFS? So many people in the space will say, hey, we need decentralized storage because that solves kind of many of the problems that I was just touching on. The problem is that's not actually true. Decentralized storage is actually a very poor way to build the cryptographic cloud, and there's a few reasons for that we've become intimately familiar with at Pinata over the years running IPFS. So number one, the problem with most decentralized storage implementations is the way that they work is that they basically cut up your data into little chunks, and then they kind of just spread them out across the network, all across the network. And the reason they do this is because they are trying to make it, decentralized, and it's not ran or being stored by one single provider. The problem with that is that really what you want when you're building an application is you want to know exactly where your data is being stored. Ideally, in a decentralized world, you know exactly where it's being stored, and you also control it as the developer, or maybe down to the end user, whatever the setup is. But ultimately, you know where it is, and you are in control of it. You can't actually do that with decentralized storage networks because, again, they chunk it up, split it up, throw it out into the network, and it's basically kind of impossible to know where that data is. So that becomes an issue. Number two, the reason why that is an issue is because what you really want is data to be as close as possible to where it needs to go. And so what I mean by that is, if you want to look at a video coming from your favorite social app, that data is being stored relatively close, like very close to you. It's not just kind of thrown out randomly into a random network. It is actually right next to, or as close as it possibly can be to, wherever it is that you are sitting. And so location matters when you need to retrieve data quickly. So IPFS solves both of those. It allows you to have complete control over the data yourself, and it allows you to have complete control over the location. And so this gives you more and better ownership and control over the data itself, while still having cryptographic verifiability through basically creating those content identifiers. And then it also can be as close or as far away from where it needs to be based on whatever application you're building. So where this is important is if you were building a local machine learning algorithm on your device, IPFS can actually run on your device. It doesn't have to call back all the way to the cloud. It can run right there locally, and IPFS has those capabilities, whereas decentralized storage protocols do not have those capabilities. Decentralized storage protocols are running out on nodes somewhere in the cloud and can't be local in the same way that IPFS can. So IPFS has massive technical advantages over traditional decentralized storage networks, and it's really a distributed storage network that has some really powerful primitives, those being the content addressable nature of it, where you can actually trust the data itself. And so this is kind of where a decentralized component of IPFS comes in, is you don't have to trust any IPFS node that exists out there for the data. So they can't change it, right? So if you ask for CID number 1 from this node, CID number 1, that file is going to show up when you call for it. And it can't be changed, it can't be corrupted in any way. And so you don't have to trust whoever's holding that data on IPFS. You can just simply trust the CID and the cryptographic nature of what's happening underneath. And that is a very, very powerful paradigm as you're trying to build out this audit trail in this verifiable data set, whether you're building for just traditional blockchain use cases or newer use cases in the AI, ML sphere of things. So the next thing that IPFS is really good at is it runs with any blockchain, whether it's Bitcoin or Ethereum or Solana or whatever. The same fundamental value that IPFS provides that I've touched on is available to any blockchain. Now, this is also true with other decentralized storage protocols. However, IPFS doesn't have its own blockchain. And so it has built-in efficiencies in that because you're not stacking blockchains on top of each other where you're relying on not only the main blockchain where a transaction is taking place, but then the decentralized storage blockchain that is trying to track things underneath. IPFS doesn't have that issue. It's just blockchain, IPFS. And that is a drastically more efficient way to build things from a technical standpoint that can't be ignored. And when you're trying to kind of manage and audit and have verification of all data, every little efficiency that you can eke out is going to be important as this cryptographic cloud is ultimately built out. And then I've already touched on this where IPFS can run anywhere, but I want to reiterate how valuable that is. IPFS can run on the smallest device to the largest computer out there, and that is a very powerful tool for any application that is being built, whether it's a data collection system out on the edge from driverless cars, or it's some super centralized financial data set. You can run IPFS anywhere. And so to summarize everything, we have in our building the cryptographic cloud. And the cryptographic cloud is this concept and this idea that all data in the future needs to be verified in a post-AI world where we can verify that this data is what it's supposed to be, and we can trust that it is what it's supposed to be. And by building this, we now have the ability to automate transactions at scale using smart contracts. And we can trust the data that the smart contracts are executing from. And then we can also use AI. We can train AI with verifiable data that we can trust. And then we can also not only train the models, but then we can also believe what data is real and what data has been processed or changed by AI. And so we can trust the data that we are also consuming. And this, again, goes from like an industrial use case data set to a financial data set to a social media data set. It really doesn't matter. The cryptographic cloud is a primitive, and it's a way of building that involves taking blockchain and taking what it's really good at, which is creating a finite amount of space, and then taking AI, which is infinite, and putting these two things together. And by doing so, we are creating this really, really powerful new computing paradigm up in the sky, if you will, and going to be able to drastically improve what we can do with computers by doing so, because we can trust the data that's underneath. So with that, hopefully that was a good primer into the cryptographic cloud. We will be doing significantly more kind of breakouts, where the cryptographic cloud has already been used, such as in the NFT space, and how ultimately this is going to work, and additional use cases that we've already seen at Pinata running IPFS infrastructure. So with that, appreciate your time.